Hello guys, welcome to another video. In this video, I'm going to be showing you how you could integrate your existing Python script into Kestra. Kestra is a powerful workflow automation tool. Let's head into their website. I particularly like their UI, which is really unique. And let me scroll down a little bit. Here we can see Kestra is actually language agnostic, which means you can actually connect any of your code which are already written in Python, Scala, C++, etc. You can define your workflows in YAML. You can integrate with any of your stack, meaning you can integrate Snowflake, AWS, DPT, Terraform, all inside one particular flow. Kestra also has many different plugins for you to play with. You can actually schedule your workflows, write triggers, execute your workflow, and you'll get something like this, a cool dynamic Gantt chart, and then you can monitor and optimize your workflows. In this video, I'm also going to be demonstrating one of my recent work in Kestra, which is extract, load, and transform ELT pipeline in Kestra, where I have fetched some of the data from Google Maps Places API and loaded that into BigQuery and did some transformation on top of it so that the final data is being useful for the data analyst. Let me give you a quick intuition about ELT pipelines or ETL pipelines. For any data engineering task, we will have a source. Maybe the source could be a REST API or a CSV or a database itself. We'll be building some data pipelines in between, and we'll be pulling this data from the source and then pushing it to a database as a target so that we can able to use this data, right? Let's look at the project architecture. Everything is gonna happen inside Kestra, which is obvious. And the first step is extract. Here you can actually see a Python file, which is gonna run the extraction logic because I don't want to write the extraction logic in YAML. And we have a places API, which is residing inside Kestra's KV store. And we are gonna pass that into the Python file, and we're gonna execute that particular file inside Kestra and then get some outputs out of it and then load it to BigQuery staging table. And then we will run some transformation logic and create two or more columns, which will be very much useful for the analysis. And for the task 2 and task 3, we will be needing GCP service account credentials, which is also loaded into Kestra's KV store. Without further ado, let's get into the project. Setting up the project. And for this, I would like to head into my GitHub repository. This is my GitHub repository where I have all the files related to the project, which I will also be linking in the description. And if you want to follow along, make sure you have all of these files in your project folder. And whatever I'm going to be showing you next in my Visual Studio Code will be exactly the same things which you see here. So make sure you have everything there so that you can easily reproduce the project which I've done. We are inside Visual Studio Code, and this is my repository. Here I have a docker compose.yaml file, which is really important here because this sets up Kestra and a Postgres DB, which is dedicated to Kestra. And we also have a DB folder here where there is another docker compose file. This file will set up a Postgres DB locally, and you can test it out by pushing data into it, which I'll be not covering in this video. And I have also added all of my scripts under the scripts folder and then all of my flows under the flows folder. Everything will be same in the GitHub, so you can find it pretty quickly. Let me now run docker compose up, which will spin up this particular Docker. And when I scroll down, we can actually see we are using port 8080, and this is the URL. Cancel. Yes, we are landed into the Kestra. Look at the UI. I think they have done an excellent work in building this particular UI. Here you can see success ratio, failure ratio, and total flows, triggers, total execution, and everything, right? All the information you'd like to see if you're building a workflow automation. The first thing in the setup is you have to get everything into your KV store. For that, you have to go to namespaces, zoom camp, which is the namespace I've been working under. KV store. Here you can see all of the API keys, all of the credentials needed for the project. How I got the values here is really simple. You just have to add a new key value pair, enter the key, place the value here, and then save. You are good to go. I've also got one of the flows from data engineering Zoom Camp, which is GCP KV. Here you have to paste all of the contents from your service accounts JSON file, right? Where you have all the credentials. Once you run this file, everything will be set it up for you inside Kestra. So it will fetch the project ID, it will fetch GCP location, it will fetch the bucket name, it will get the data set, GCP data set too. Let me head back here. For security reasons, I can't be showing you the particular file because I have all the credentials there. Make sure you're also keeping it secure. Let me head to the flow, which will do the ELT, extract groceries. I'm gonna edit the flow now. The first step in creating a flow inside Kestra is you have to define an ID and namespace so that you'll let Kestra know that you have this particular flow under this particular namespace. Extraction. So let's see how we are going to extract the data. The first task, we are defining it here. One of the best features about Kestra is Kestra has a lot of plugins, one of which is Python commands. We have enabled the namespace files true because we have to fetch the KV values from the namespace. We also have to run the scripts from the files, right? And here I have defined a task runner and container image PyData for running the Python commands. And these are the before commands. You can actually install all of the dependencies before you run the Python file. And this command is going to run the Python file. And we are passing the places API from KV store as well. And finally, we are just defining output files as all the .csv files which the Python file is going to generate. And let me just quickly head to the files. And you can create your new files here. That's how I got it here. And the extraction logic is here. Here I've used argpass to just pass on one of the API keys through the command line. Once we got the API, I'm just creating a variable for location and radius, which specifies Coventry city center. And I've got some of the top retailers from ChatGPT for fetching the data from Google's API, which are Tesco, Asda, Sainsbury, Morrisons, etc. And this is the Google's places URL. Finally, we're going to fetch these values from here. Once the fetching is complete, we'll have it in JSON format, and we are converting the JSON to a data frame using pandas. And finally, we are going to export it to CSV. And finally, we're going to export it to CSV. So this is the Python file. You can actually test it out in Python Jupyter Notebook first, and then build the entire flow, and then import Kestra here, do a little bit of tweaking, and then finalize the file for the execution, right? The next step is loading the data into BigQuery. One of the cool feature I like about Kestra is they already have the YAML commands, and when you see, it's really simple. You just have to call the BigQuery loading plugin, and then you have to specify from where you're taking the data set, which is from the output of the previous task, and then the destination table, which has the GCP project ID, GCP dataset, and the table name. And the format is CSV. Schema is auto-detected here because I've mentioned it. And the delimiter is comma, and the location is also taken from the KV store. And you can actually see the power of Kestra here. Just within a few lines of code, you're going to push the data to your Google BigQuery. And then the next step is transform. For the transformation, we'll be using simple SQL commands to just create a new table and then have all the fields which I had previously. And I'm going to add two new fields. One is trust score, where we calculate that using this little formula here. And then the next one is distance from the Coventry city center. And after getting these values, we're going to push it into the final table. Last but not least, never forget this particular plugin defaults for Kestra to actually access GCP services. You can also find this in my GitHub repo. Just head over there, copy this plugin defaults, and then paste it here. I have also created a blog which I will be releasing in a short period of time, where you can actually see the bits and pieces of code here and there explained, and you can just copy and paste it. I think this will also be another good thing for you guys to just copy and paste and then understand what each and every single code block is doing in this complete ELT process, right? Do check this out, and if you just like it, just give a thumbs up and link it. Yeah. Let me head back to the flow now. And the next step would be running the flow. We'll be running this flow, and we are here at the final step. But before running the flow, I would like to show you my GCP's BigQuery table, because we just have to make sure that nothing is there. And then once we run the flow, we are getting the output there. This is my GCP console. This is the project ID, which I'm currently working under. This is the dataset, grocery stores reviews. Currently, there are no tables under this dataset, but once we run the flow, we'll be getting two tables. One is staging and one is the final table. Let's execute the flow. I'm gonna click execute here, and then the flow started running. The first task is extraction. I think the first task will take a bit of time because we are gonna fetch some values from Google's API. And I really like how dynamic these Gantt charts are. You can actually see it's now loading the data to BigQuery, and it's green, and then it's transforming the data inside BigQuery. It's also green. It's completed now. The time we taken to run this ELT process is 31 seconds. Before heading to GCP, I'd like to show the output files from the Python here. And when you go to the output files, you can actually see the convenience stores coventry.csv. You can download it or preview it here. You can actually see the data, right? These are the data we will be pushing to a staging table inside GCP BigQuery. I will quickly refresh the contents here. Yes. Now we have two tables. One is staging and this one is the final table. And you can actually see the details. We have 65 number of rows, which we got from the Python file. And then after doing some transformations, we have 62 rows. And we can actually preview the data. And we got the two new fields or columns which we created: trust score, distance from Coventry City Center. If you would like to query the data, you can actually do that in BigQuery as well. You just have to query the data in a new tab, and you can actually run the query. It will just return all of the items here because I mentioned star, select star, right? So it's a great success that we have built an ELT pipeline inside Kestra really fast, which actually pulls data from Google's Places API and then pushes it to a staging table inside BigQuery, and then do some transformation on top of it, and then create our new final clean table. I have pushed this little bit further to create a Tableau dashboard by connecting this BigQuery table inside Tableau to provide some actual value out of this data. So this is the final dashboard I've built. We have four different plots here, three of which are bar plots and one is a geospatial map plot. The first one is distance from city center, which gives us distance of all the grocery stores from Coventry city center. The second one are their respective ratings, where Co-ops, Morrison's, Aldi got the top three spots. And this is the trustworthiness which we calculated, right? As we transform the data, we created two new fields. And the third one is trustworthiness. If you see a place with a 5-star rating and with a few rating count, it is actually not genuine, right? That's what we are trying to calculate with this field. And by seeing this, we can actually see Sainsbury, Lidl, Morrison's, and Aldi. They have a good trustworthy score, and we can actually trust them. And we can also see all of the grocery stores location in this map here. And I think considering the distance from city center and trustworthiness, Sainsbury's is my go-to choice in Coventry. I always shop in Sainsbury because it's very nearby. Now we are at the end of this video, and I would like to thank all the people who watched the video till the end. And I would also like to thank my mentors from Data Engineering Zoom Camp who taught me this amazing new tool called Kestra. And I'm really grateful to all the support I got in this week 2 of learning data engineering with them. If you like this video, just drop some thumbs up. And if you have any doubts or a specific query, or if you got stuck somewhere in between, just let me know in the comment section, and I'm more than happy to help you guys out. I hope everyone would able to integrate their Python script into Kestra once they see this video. If you do anything like that, please share that with me in the comment section. Thank you guys. Stay tuned for more contents like this. Thank you.